question for figure Q 15.4 shows a position versus time graph for a particle in SHM. A. What is the phase constant? Phi 0. So in order to do this question, we need to write the equation for position versus time in SHM. This is the equation. X as a position of time equal amplitude times cosine of omega t plus phase constant. Let's gather a few data. We know that at time 0, x is at the half of the amplitude. And for this problem, we don't need to find omega because we basically at time 0, anything multiplies by 0 is going to be 0, so we are not going to bother ourselves to find omega here, and also the question didn't ask us to do it. So at time equals 0 second, x is half of amplitude equal amplitude itself times cosine of phase constant. Let's simplify this equation. Let's divide half amplitude by amplitude. Half amplitude divided by amplitude gives us half. Why? Because half amplitude divided by amplitude, we give it a 1 as denominator. We distribute it like this, and 2 times a. We eliminate a and a. We get half. Then here, half equal cosine of phase constant. Then we move the cosine to the other side to find the angle. It's gonna be cosine times power minus 1, or arc cosine of half equal phase constant. Then we get positive or negative 1.047 or positive minus negative pi over 3 equal phase constant. Why is positive and negative here? Because whenever you find an arc, you use arc cosine to find an angle, you get a positive and negative value for the same angle. But your calculator only shows the positive one, or just one of them. Then the next step is to find whether the pi over 3 is positive or it's negative. In order to do that, we have to go back to our graph. In the graph here, based on the graph, the particle is moving toward the positive amplitude here. Let's draw our, here on the linear graph, we are almost here and we are moving to the positive amplitude. Let's draw this reference circle. Here is the pi over 2 equilibrium, and here is minus pi over 2 the equilibrium. Here is the positive amplitude, here is the negative amplitude. Here is pi over 6, pi over 4, pi over 3, minus pi over 3, minus pi over 4, minus pi over 6. Since we left the amplitude, we left the equilibrium point, which is here, and we are moving toward the positive amplitude, we must be in this section. And it's gonna be either positive pi over 3 or negative pi over 3, and negative pi over 3 is the best one that fits our description. So the phase constant is minus pi over 3. Phase constant, negative pi over 3. Let's write our position versus time equation again. X as a position of time equal amplitude A cosine omega t minus pi over 3. So that is the first part of our equation, of our question. Let's do the second one. What is the phase constant of the particle at each of the three numbered points on the graph? We know by now that this point here is basically not the middle of our graph. I mean, like, not middle of the amplitude and the equilibrium. It's actually pi over 3. And here is pi over 3. Let's go back to our reference circle. Let me just clean it up a little bit. Perfect. And let's just complete our reference circle. 3 pi over 4 and 5 pi over 6. And here it's gonna be minus pi over 6, minus 3 pi over 4, and minus 2 pi over 3. The point 1 here, it's at the point where we just left the negative amplitude here. Here, this is the negative amplitude, and we are moving toward the equilibrium. Here, this equilibrium. Why not the other equilibrium? Because this equilibrium means we left the negative amplitude and we are moving to the positive amplitude. And this must be minus 2 pi over 3, because it's the negative part of pi over 3. Point 1. Let's now do point 2. Point 2 is pretty easy. We are at the positive equilibrium here. Point 2. Let's do the point 3 now. Point 3, we just left the equilibrium, the one that comes from the positive equilibrium, from here. This equilibrium. Because we left the positive equilibrium, positive amplitude, we passed by the positive equilibrium here, and we are moving to the negative amplitude. We are on our way to negative amplitude. So we are at this point, point 3. Point 3. We are at 2 pi over 3. So it's 2 pi over 3. Here is 0 pi or 2 pi, and here is negative 2 pi over 3. Thanks for listening.